central dogma of molecular biology. Okay, so to continue their replication cycle, first they must reverse transcribe their plus-strand single-stranded RNA into double-stranded DNA before they can use that double-stranded DNA as template to synthesize mRNA and translate into protein and form the new virion. So as you can see, they have to go backward, upward the central dogma of molecular biology from mRNA into DNA, then using the double-stranded DNA to synthesize mRNA and then protein. So they always go retrovertly, they go backwardly up the molecular biology scheme. And that's why all the virus that require this unique mechanism for replication is called retrovirus, because they go backward, they go upward the central dogma of molecular biology. Okay, this is a cartoon representation of basic retroviral replication cycle, which composed of 6 steps. Firstly, the virus must attach to the target cell by the specific interaction between the envelope glycoprotein of the virus with specific receptor on the cell surface. In case of FIV, the example here, FIV require two receptor, the CD134 and the CD4 for binding and enter to the cell. After this specific interaction between the glycoprotein and the cellular receptor, the virus will undergo membrane fusion, fusing the viral membrane and the cell membrane to allow the RNA genome of the virus to be released into the cytoplasm of the infected cell. Here in the cytoplasm, the retrovirus will undergo one of the unique characteristics of retrovirus, which is reverse transcription, transcribe backwardly from RNA into double-stranded DNA here, and then move into the nucleus to undergo another unique characteristic of retroviruses, which is integration of double-stranded DNA into the host genome, which now we will call proviral DNA. The virus will then use this proviral DNA as a template for both RNA transcription and also for the synthesis of a genomic RNA of the virus. The mRNA transcript will then move out into the cytoplasm, where they undergo protein synthesis and also encapsulate the newly synthesized genomic RNA into the virus virion and move to the cell membrane, where there is envelope glycoprotein already produced waiting there and bud out of the cell and get into the another cell and continue the infectious cycle. So I just want to remind you that retrovirus have two unique characteristic mechanism of replication. The first one is reverse transcription from RNA into double-stranded DNA. And secondly, the integration of double-stranded DNA into the host genome, which then we will call proviral DNA. Because of these two unique characteristics of retroviruses, all retroviral infection will be considered persistent infection, in which the virus will persist and remain in the host genome until the host dies. Okay, enough for the basic biology of retrovirus. Let me start with the first important retrovirus in the veterinary field, Fplv or feline leukemia virus. Of course, Fplv belong to the family Retroviruses, being a retrovirus, but Fplv belong to different genus from FIV. Fplv belong to the genus Gamma retrovirus, which is a rather ancient and simpler than FIV. The genome of Fplv only encoded for structural protein and non-structural protein, or the enzyme that were used for replication. And on the left side of the screen, this is a basic cartoon representation of the virus virion. It is an envelope virus, so I have the envelope surrounding the virus core. On the envelope, the virus have the envelope glycoprotein, which composed of the surface GP70 and the transmembrane portion P15E. Underneath the envelope of the virus is underlined by matrix P15 protein. And inside, in the center of the virion is a virus core, composed mainly of the capsid P27. And inside the capsid core is the pseudo-diploid single-stranded RNA of the virus together with the enzyme that the virus will use when want to undergo replication. By looking at the way surface GP70 interact with the cellular receptor, we can divide Fblv into three main subgroups: subgroup A, B, and C. I will talk more about that later. And Fblv transmit mainly by direct transmission, by close contact, by saliva. I would always imagine Fblv as a virus of love, like cats that love each other, have the intimate interaction, have grooming each other, and they transmit the virus with the grooming activity of the cats. Yeah. Fblv also have an age-related resistance in which host immune response is very important, is play an important role in controlling Fblv outcome. And therefore, in kittens where the immune response is not well developed, not mature yet, have higher risk of having severe Fblv infection outcome. As I mentioned in the last slide, we can divide Fblv into three subgroups according to the receptor the Fblv use. Fblv A, the major exogenous Fblv that transmit amongst cats, use this receptor called thiamine transporter, which expressed in several tissues of the cat. And that's why Fblv have a very broad tissue tropism, can infect several other tissues at the same time. And that's why Fblv A is the mostly transmitted between cats. The clinical manifestation of Fblv A is mainly could be macrocytic anemia or immunosuppression, depend on the level of replication that ongoing in the cat bodies. The second subgroup, Fblv-B, Fblv-B arise from the recombination between Fblv-A, the exogenous Fblv that infect into the cat, and endogenous Fblv that already inside the host, inside the cat genomes. And result from this recombination event is switch from thiamine transporter into another receptor, which is called phosphate importer. Somehow, Fblv-B was always believed that is associated with neuropatia, but some of the tumor DNA analysis study showing that mainly the DNA of Fblv, the genome of the Fblv in the tumor are composed both of Fblv-A and Fblv-B, and therefore there's some belief that the association between neoplasia and Fblv-B is actually reflecting the later stage of Fblv infection, in which the recombination has already occurred inside the cats. Another subgroup of Fblv, Fblv-C, arise from the de novo mutation inside the cat of Fblv-A surface glycoprotein and switching from thiamine transporter into heme transporter, which is very essential for erythroid progenitor. And that's why Fblv-C is always associated with red blood cell and non-regenerative anemia or red blood cell aplasia. But Fblv-C is rarely found, only about like 5% of Fblv infected cats. Mainly the dominant subgroup of Fblv is Fblv-A. Now let's look at the outcome of Fblv exposure. As I mentioned earlier, Fblv transmit via saliva and like intimate interaction between cats, grooming activities. So the first Fblv get into the cat via oral nasal exposure and will start replication in oropharynx and tonsil. However, at this very early stage of infection, if the cat already immune to Fblv, for example, vaccinated against Fblv, or fully mature, strong, healthy cat, the cat can mount an early strong immune response against Fblv and stop Fblv replication. We call this type of infection an abortive infection, in which the virus replication is stopped before it's going to like secondary lymphoid tissues. However, in most of the cat, the immune response did not come as early as the abortively infected cats, and allow virus to replicate enough in oropharynx and tonsil and start to get into the circulation via associated with lymphocyte and monocyte and create a primary viremia, in which the virus will migrate into other lymphoid tissues. At this stage, if the cat can mount a strong immune response, although rather late in the clinical course, the immune response can control and contain viral replication. We call this outcome a regressive infection, in which the cat will show transient viremia, only the primary viremia, but the replication is stopped before it continues to the bone marrow. Unfortunately, in a small number of cats, the immune response is not strong enough to control viral infection, and therefore there's come the secondary viremia, and the virus can migrate into the bone marrow and have infection and have infected the hematopoietic precursors. In this cat with poor or absent immune response, the Fblv, we call it infection a progressive infection, in which the cat will continuously viremic. We can detect virus at all time because the virus have already get involved in infect into the hematopoietic precursors, and only this group of cats have a lower quality of life compared to normal cats, and also will show like at some time in the clinical course some Fblv associated clinical manifestations such as neuropathia, immune suppression, and also anemia. Now let's look closely at each type of infection. As I mentioned earlier, cat infected with virus via oral nasal exposure. In these abortively infected cats, the immune response come very early at the very beginning of the infection, where the virus just replicate shortly in the oropharynx and tonsil. With strong neutralizing antibody titer and also some T cell response, the virus replication is controlled, and therefore the infection is not well established. We can actually call this abortively infected cat another term such as exposed but not infected. The cat is exposed to the virus, but infection failed to establish, right? And in this abortively infected cat, we will not be able to detect any component of the virus in the cats. We cannot detect plasma viral RNA. We cannot detect proviral DNA because there is not enough integrated cells, or it's already been like killed by T cell response. And also we cannot detect P27 capsid antigen, which show like ongoing viral replication. The only mean to identify this abortively infected cat is by presence of antibody, whether it is against P15, the transmembrane portion of the surface glycoprotein, or the GP70, the surface portion of the glycoprotein. Recently, some study in Germany and Austria show that abortively infected cat is more common than we expected, which approximately about 4 to 11% in the German and Australian owned cats. Yeah, we still haven't got any data on the Asian cats. Yeah, but let's see. Another type of infection, another outcome of exposure is regressive infection. In these regressively infected cats, virus replication is already ongoing and the primary viremia is already occurred. So that means there is higher degree of viral replication in the cats. However, when the immune response start to fight back against the virus replication is contained but cannot be eliminated. As I mentioned earlier, after the integration of proviral DNA into the host genome, it will persist with the host until the end of lifespan of the host. In these regressively infected cats, we can detect and we can identify them by detecting of proviral DNA because the integration has already done. However, for the plasma viral RNA or the P27 antigenemia, it will only be about 4 to 12 weeks after infection because the viral replication can be contained. So you can no longer detect the antigen of the virus or the viral RNA of the newly synthesized virion. The only mean to detect these regressively infected cats is by detection of proviral DNA in the genome of the cell. The percentage of these regulatively infected cats in Germany and in Australia study is about 1 to 2%. But when you look at the, I would say, densely populated settings such as metropolitan, such as Bangkok, I mean, I found about 30% of regulatively infected cats because the cat is allowed to roam around, and it's a survival of the fittest. The one that get infected and have clinical symptoms will pass away. But the one that fit enough to control the virus replication will survive. And that's why we see such high percentage of regulatively infected cat in densely populated settings such as Bangkok. The last outcome of Fblv exposure is these unfortunate cats, which is the progressively infected cats. These cats, because they cannot mount a strong enough immune response to control replication, the virus continue to replicate, have primary viremia, and then secondary viremia, and get into the bone marrow and infect of hematopoietic precursors. These cats have no antibodies, so always tested antibody negative. But when you look at the laboratory readout of all the viral component, you can detect viral RNA in the plasma. You can detect proviral DNA in the blood cell. You can always detect P27 antigen in the blood as well. So the replication is ongoing. That's why we term this cat a progressive infected cat, because the infection is and continue. Yep. The number of this cat is about 0.5 or 2% in German and Australian owned cat, but also quite as high, about 10% in the same in Bangkok, the same highly densely populated setting. Yeah. And this is the group that you really have to pay attention to. They will have shorter lifespan compared to uninfected cats. They will, at some point of their life, they will show some Fblv related clinical manifestations. So next, let's move to Fblv diagnosis. The indication for Fblv testing is including when you first acquire the cat without any history before, you must make sure that the cat is not infected with Fblv, whether it's for your household or for the shelter setting. The next indication is before you give vaccine to the cats, you must make sure the cat haven't been infected with Fblv, because vaccination is only beneficial in naive cat. Another indication is when you're quite concerned about the cat exposure to Fblv. Let's say it's the indoor cat that get loose and get out and have a fight with neighbor cats and come back with a bite wound or something like that. There's a chance of Fblv exposure. And of course, when the cat show clinical sign of Fblv, such as anemia or immune suppression. Because Fblv is a systemic infection, therefore the specimen of choice for diagnosis is either blood or serum sample. For a serology test such as ELISA that aim to detect Fblv specific antibody, serum from, let's say, whole blood is the specimen of choice. And also for the point of care test that aim to detect Fblv specific antigen, the whole blood is also specimen of choice. But for molecular diagnosis methods such as PCR, RT-PCR, I would recommend you use anticoagulated blood tube such as EDTA as a sample, as a specimen of choice. And for viral isolation, I would recommend you use heparinized blood tube, because heparin is less toxic to the cell culture system than EDTA. And the gold standard of Fblv diagnosis is, of course, virus isolation, the same as all virus diseases. I'm quite certain you're all familiar with Fblv point of care tests. There are tons of several brands of Fblv point of care tests available in the market. But as far as I know, every single brand detects the same thing for Fblv, which is the capsid protein of the virus, the most abundant protein of the virion, the P27 capsid protein. And regardless of the detecting method of the platform of the test, it detects the same things. So next, let me give you some background about the different type of point of care tests that we use in the clinic right now. The first one is lateral flow immunochromatography, the most popular format, I would say. The lateral flow immunochromatography format can be used to detect both the antigen and also the antibody. So let me start with the antigen detection format on the left side of the screen. So the antigen detection format is aimed to detect viral specific antigen in the sample, in this case blood for Fblv test, which represented by the blue oval shape in the blood here. Lateral flow immunochromatography backbone is the membrane that allows the liquid phase to flow laterally from left hand to the right hand here. And along the flow path, there will be some molecule that will make the test work, as shown by the cartoon here. Here at the reservoir, just after the pad that detect that soaked up by the blood sample, is the monoclonal antibody against viral antigen, in this case against Fblv P27 antigen that conjugated with gold nanoparticle. If in the blood sample contain the P27 antigen of the Fblv, it will specifically bind with the monoclonal antibodies that conjugate with gold nanoparticle and migrate from left to right along the flow path. When it reached the test line, which coated with another clone of antibodies against the same antigen, P27 antigen, it will form a complex. Similarly to the sandwich ELISA, you see the monoclonal antibody on the test line, then the antigen antibody complex that flow from the reservoir here to here. And because of the chemical characteristic of gold nanoparticle, when they pack closely to each other, they will form the red line as shown here on the test line. The second component of the lateral flow immunochromatography is the control line, which code for another monoclonal antibody clone, but against the immunoglobulin heavy chain of the first antibody. To make sure that the flow path is complete, the antibody here is flow to the right hand side here. So if the blood sample contains P27 antigen, you will see two red lines, first on the test line and secondly on the control line. But if the sample doesn't contain the antigen that you want to detect, you will only detect one red line on the control line. Similarly, on the antibody detection format, such in the case of FIV kits, we just swap the detecting molecule on the test line. On the antigen detection method, we coat it with the monoclonal antibody against the antigen that we want to detect. On the antibody detection format, we coat with viral specific antigen because we want to detect the specific antibodies against the antigen that in the blood. So when you first drop the blood into the test, the blood will be specifically bound with the monoclonal antibody against the immunoglobulin of the cats, against feline immunoglobulin, and migrate from left to right. When it reaches the test line, this red antibody in the blood, specific to FIV antigen, will bound to the antigen coated on the test line. And because of the same gold nanoparticle property, you will detect the red line on the test line here if there is antibody in the blood sample. And the same on the control line to guarantee that the antibody has flow from left hand to right hand. The lateral flow immunochromatography has a lot of advantage. Firstly, they are very robust. You can store them in at room temperature, and they're quite straightforward, no nonsense, simple to use, just with a 2-3 drop of blood, and that's it. You can detect the readout by whether it's one line or two red line. But there are also disadvantage of the lateral flow immunochromatography. Firstly, if the sample is hemolyzed, the hemolytic background, the red background, can interfere with the readout when the molecule that you want to detect is not dense enough. You cannot distinguish between the background, the red background from hemolyzed blood, and the red line of gold nanoparticle. Yeah. And also the intensity of the band of the line here is really depend on the quantity of the molecule that you want to detect. If there is not enough quantity, you might have some false negatives. Yeah, such and such. Another I would say commercially available platform of the point of care test is the SNAP test, which is slightly different from the lateral flow immunochromatography. SNAP test is a true ELISA, a bidirectional flow enzyme link immunosorbent. So the principle of SNAP test is ELISA. That means there must be some enzymatic activity and to amplify the signal of the test. So if you look at the figure here, firstly, when you will combine the blood sample, you will mix the blood sample with the solution provided by the test, in which inside have the antibody against, let's say, Fblv P27 antigen or antibodies against FIV. But that antibody is conjugated with enzyme, and not nanoparticle. And when you drop your mixture into the reservoir pad here, the first direction flow will start from left to right here. When it flow past the spot where, let's say, another clone of monoclonal antibodies against P27 antigen is coated on the spot, it will act as a sandwich ELISA in which the antigen is trapped on the dot with the enzyme conjugated antibody point upward. And when you click the snap button, you will break two reagent reservoir. The first one is the wash buffer that will wash away all the non-specific binding on the spot to give you the clear background on the test. And the second reservoir is where the chromogen and the substrate for enzymatic activity is. And it will flow another direction backward from right to left. That's why we call it bidirectional flow enzyme link immunosorbent. Yeah. And because they have the enzymatic activity, it can amplify signal. So that's why you can see the blue signal amplify from the antigen antibody activity here. So the advantage of SNAPs is that it can amplify the signal, and they have the wash buffer to wash away the background. So you see, if it's positive, you see the quite clear background and like amplified signal of the detecting molecule. However, because of the use of substrate and enzyme, it is not as robust as lateral flow immunochromatography and must be kept at 4 degrees throughout the shelf life. So pro and con, and also slightly more expensive, I think, because of the patented design. But that is the most commonly used point of care test format available in the market right now. So now we understand about the background, the format of the test. Let's see how the test perform in the field setting. When you read about the performance of the, let's say, Fblv test in the field setting, please bear in mind or please read carefully what is the gold standard method that they use to compare the performance of point of care test with. Because all point of care tests against Fblv detecting P27 antigen. So any test that compare performance of the test, the point of care test with molecular technique is not fair, because the antigen detection sensitivity is of course lower than the molecular detection method. And also, as I mentioned earlier, antigen P27 antigenemia only happen in progressively infected cats. That means point of care tests that are available in the market right now can only detect progressively infected cats and not regressively infected cats, but the molecular technique can. So when you want to compare the performance of the test, I would suggest we can only believe in the test that use another gold standard test that also detect P27 antigen, such as P27 ELISA here. So there are so far only 2 studies that compare point of care test performance using ELISA technique. And as you can see the number on the slide, most tests show comparable sensitivity and specificity in progressively infected cats. Yeah. Also, with the clearer background of the SNAP, you can see the sensitivity is slightly higher, but I would say all of them are comparable in terms of sensitivity and specificity, but only in progressively infected cats. Because when you look at the another studies that compare the point of care test with gold standard using a molecular techniques such as qPCR, quantitative PCR, or conventional PCR, you can see that the sensitivity is dropped about half, about 50%, because point of care test can only detect antigenemia in the progressively infected cats and cannot detect regressively infected cats. And that is the most drawback of all point of care tests available in the market right now, they cannot detect the cat without antigenemia. So you might require, so whenever you perform a point of care test for Fblv, even if it turns negative, you have to bear in mind that there is a chance that the cat is regressively infected, and you should like confirm by using molecular techniques such as PCR. So this slide is summary of the Fblv infection outcome and diagnostic summary. Firstly, the first type of infection, the first type of Fblv exposure outcome, abortive infection. In these abortively infected cats, the viral replication is completely controlled. So therefore, there is no viral shedding. There is no Fblv associated diseases. Unfortunately, because they already like exposed to the Fblv and mount a strong immune response, vaccination is not useful in this group of abortively infected cats. The only mean to detect abortively infected cat is by detecting neutralizing antibody, such as using serum neutralization test or ELISA, and it will be strongly positive in abortively infected cats. But if you want to detect P27 antigen, viral DNA or plasma viral RNA, or even viral isolation, they will come out negative for abortively infected cats. For the second group, regressively infected cats, there is no viral shedding because the viral replication is contained, already controlled. Fblv associated disease is rarely observed in these regressively infected cats, but we never say never, because regressive infection can be reactivated by immune suppression. For example, in the cat with regressively infected status of Fblv, they co-infected with FIV that suppress the immune response, there is a chance of reactivation of Fblv replication. So therefore, we would say rarely observed, but it's possible. Yep. Again, vaccination is only useful in true Fblv naive cats, and therefore regressive infected cat already mount a strong immune response, have a detectable level of neutralizing antibodies. So therefore, vaccination is not very useful in regressively infected cats. If you want to detect P27 antigen in this regressively infected cat, the window of detection is quite short, not like no later than 3 months after infection, because it can control. So I would say transient P27 antigen. The only mean to detect regressively infected cat is by detecting viral DNA integrated in the host genome, which always turn positive. For plasma viral RNA, again, it's only positive during the early phase of infection, during the replication, active replication, so also transient, similarly to the antigenemia. And of course, you cannot isolate the virus from regressively infected cat unless you give them the immunosuppression to reactivate the latently infected cat, the latently infected cell to reactivate and start replication again. The last group of Fblv infected cats are progressively infected cats. In this group of cats, you can detect any aspect of Fblv infection without. You can detect the viral RNA. The cat will show some Fblv associated diseases. Fblv P27 antigen always be positive. Viral DNA are positive, and you can isolate virus from this infected cat. The only component that miss out is the neutralizing antibody, because the virus, the cat cannot mount strong immune response. There is no antibodies against Fblv in these progressively infected cats. Excuse me. And the best tool to prevent Fblv spreading in your population is by identification and isolation. Point of care test is a sensitive mean to detect and to identify Fblv infected cats. Just bear in mind that if you're quite concerned that the cat is already infected with Fblv and it tested negative on the point of care test, please confirm with other techniques such as molecular technique and isolate the cat from the uninfected cat to prevent like spreading of the disease. Fblv vaccine is very efficient, have like a very strong protective immunity and indicated for all at-risk cats. However, in some cases, Fblv vaccine might not provide sterilizing immunity, which I mean the cat can still be infected with Fblv, but by like vaccination against Fblv, you can decrease the chance of having progressively infected outcome. But bear in mind, you must always test for Fblv before vaccination, because Fblv vaccine only beneficial in true Fblv naive cats. Right. We move on from Fblv to another important feline retroviruses, feline immunodeficiency virus or FIV. Same, I would say, basic character of the virus. It belongs to the same family, Retroviridae, and is an envelope virus. On the surface, have surface glycoprotein, but the size of the protein is slightly different. It is GP70 in Fblv, but it's GP120 in FIV. And it's GP15E in Fblv, but it's GP40 in FIV. It's just the size of the protein. Because if FIV is slightly more complex, so the protein is slightly more complex, put that way. But also underlying underneath the envelope membrane with the P17 matrix, inside have the core of capsid P24, and have two pseudo-diploid single-stranded RNA genome with the enzyme of the virus. FIV belong to another genus of retrovirus, which is a genus called lentivirus. Because of the name, lenti, it's like Lent period in the religion aspect. So the FIV is belong to genus lentivirus because the asymptomatic phase of FIV infection is quite long, like the virus being in the Lent period, and one day the virus like come out again and create the 8th phase of the virus infection. But we talk about that later on the natural history of FIV infection. When we look at the sequence of the surface glycoprotein, the GP120 here, we can divide FIV into 6 clades or 6 subtypes, A to F. And like all retrovirus, there's some recombinant event happening in the population of the virus. There's an evidence of A and B recombination, A and C recombination, and A, B, C triple recombination in the field. Yep. Compared to Fblv, the virus of love, I would say FIV is the virus of aggressiveness. Also transmitted by direct transmission, but mainly via territorial fighting and biting. So that's why I say FIV is the virus of hatred. Yep. So the complete outdoor male have 2 to 4 times higher risk of getting FIV infection compared to the indoor castrated tomcats, because they fight to protect their territory. Unlike Fblv, FIV has geographical distribution as I show on the slide here. In North America, you see all the 3 main subclades, A, B, C, and also the recombination between A and B and C. B and E is mainly in Southern America, mainly in Argentina. In mainland Europe, in the southern part is B, subtype B. In the north is subtype A. In Asia, I don't know about China, but in Japan, you can see A, B, C, D, 4 main subclades. Yep. And in Southeast Asia, you see mainly clade C in Vietnam and clade D in Thailand. Yep. Australia, you see clade A. And in New Zealand, you see the new clade F, and also the clade U, another unique clade that found only in New Zealand. And because the virus is transmitted by direct transmission, so you see the geographic distribution that separate one clade of virus from another clade of virus, because the limited movement of the cats of the host. So right, this graph shows the classic natural history of FIV infection. On the y-axis on the left-hand side is lymphocyte count. On the y-axis on the right-hand side is plasma FIV load, the number of virus in the blood circulation. On the x-axis is time. We start with the early phase that we count in weeks and then change to years because of the long asymptomatic phase of FIV, the lentivirus. If you look at the black line here, which is the CD4 T lymphocyte, the main target cell for FIV, which normally start as like different from cat to cat, but around 750 cells per cubic millimeter. After exposed to FIV, you will see the rise of FIV viral load in the blood dramatically rise, concurrently with the decline in CD4 T lymphocyte, both from FIV infection and heavily activation of CD4 T lymphocyte. At about 4 to 6 weeks post-infection, you will see the rising of the CD8 T lymphocyte specifically against the FIV infected cell. And that's why you see the decrease in number of FIV load and slightly increase of the CD4 T lymphocyte. But the level will never reach the background before infection of the cat, because some clone of CD4 T lymphocyte have already died from the infection of the early phase. And at about, let's say, 1 month to 2 months, you will detect specific antibody against FIV, the green line here. When virus is controlled to the lowest limit of the virus in the circulation, and the CD4 rebound back to the highest level after infection in the early phase, we will call this transition or this point as viral set point. This is the point separate early phase and asymptomatic phase. During the asymptomatic phase, as you look at the graph, there seem to be like ongoing replication of the virus and also ongoing control of the virus by antibodies and also by the CD8 T lymphocyte. So it's like a competition between virus to evade immune response, to come up with new variant, and the immune response to catch up with the variant of the virus. So it put a lot of stress on immune response. After a certain period of time, I would say 3 to 5 years, you will see the decline in both in all the arms of immune response: CD4 T lymphocyte, CD8 T lymphocyte, and also antibody, and also an unstoppable rising in the number of viral load. At this point, because the CD4 T cell number is too low to prevent another, let's say, opportunistic infection, you will see the cat come to you in the clinic with FHV, recurrent, with FCV, with other respiratory infection that associate with immune suppression. And that is, at this point, we call the terminal phase or 8th phase of FIV infection. To diagnose FIV have the same indications as Fblv. You want to diagnose FIV when you first acquire the cats, or prior to vaccination, or after like certain exposure event, get out of the house and then get bitten by another cat, something like that. Also when the cat show clinical signs such as like uncontrollable FCV infection or recurrent FHV infection, something like that. And also FIV is a systemic infection, so the specimen of choice is a blood or serum sample. For serology tests such as ELISA, Western blot, or immunofluorescence assay, which aim to detect FIV specific antibody, the whole blood, the serum, is the specimen of choice. Again, for molecular diagnosis such as PCR or RT-PCR, I would suggest EDTA blood. And for blood isolation, I would suggest heparinase blood sample because it's less toxic to the cell culture system. And also similar to Fblv, we can aim to detect both viral RNA in the circulation and also proviral DNA in the blood cells. To my experience, I would say detection of viral RNA have lower sensitivity than proviral DNA detection, because unlike the counterparts in human HIV, FIV load, FIV RNA is not as high as HIV. So we tend not to use FIV RNA as a detection method for virus circulation, but instead we use proviral DNA. So the point of care test for FIV is slightly more complex compared to Fblv. For Fblv, all brand detecting the same thing, the P27 antigen capsid protein of the virus in the blood. But for FIV, they all detect antibodies against FIV, but with different specificity. Like look here on the table here for the BioGuard Fblv antigen FIV antibody combo. They aim to detect antibody against both the capsid protein here, the highly immunogenic protein, capsid protein, and also the transmembrane portion of the glycoprotein GP40 here. For the IDEX SNAP test, they just want to have highest sensitivity as possible. So they detect antibody against 3 proteins, the P15 nucleocapsid, the P24 capsid protein, and also the transmembrane GP40. For other brands such as Zoetic Witness and Biono Antigen, they aim to detect only antibody against transmembrane GP40 protein here. And for Abbasid West scan, they detect only antibody against capsid protein. When you choose point of care test against FIV, you have to remember what the target of antibody that they use in the test kit, because it might help with your interpretation of the test outcome, of the test result. I will tell you about that later. Oh yeah, here I just want to show you like different tests that detect different antibody against different protein have some slightly characteristic. Look at here in the study by my supervisor back in University of Glasgow and Dr. Brian Willett. It's a Western blot of the cat experimentally infected with FIV, and on the each strip is at different time point, and it's a result from 3 different cats. And the top row is antibody against envelope glycoprotein, the GP120 and the GP40. The second one is CA or capsid, again capsid P24, and MA is again matrix P17 here. So as you can see, in all 3 cats, antibody against capsid, or let's say again P24, is the first one that detectable as early as 3 weeks after infection, followed by the matrix antibody against matrix proteins at about 6 weeks post-infection. The antibody against envelope glycoprotein, because of the limited number of envelope glycoprotein on the virion, envelope glycoprotein is not very immunogenic, and that's why you can detect antibody against envelope glycoprotein only at later point post-infection, such as here in this cat at 10 weeks. This cat you see about 10 weeks, but very faint band. That means the quantity of antibody is really, very low compared to against capsid protein and against matrix protein. And I think that is one of the reasons why most of the kit, let's say 3 out of 5 commercially available kit, designed to put P24 on the test kit, because P24 is the main, like, and the most immunogenic target for antibody against FIV. So to summarize here, antibody against capsid, can be detected as early as 3 weeks, followed by antibody against matrix protein P17 and P15, and then the GP40 at later time, like 10 weeks after infection, but slightly lower quantity, lower sensitivity. Now that we know about FIV point of care test, let's look at the performance. The gold standard for FIV diagnosis is, of course, isolation, because antibody can come also from vaccination. So the only way to confirm that antibody that you detected by your point of care test, it comes from infection and not vaccination, is by isolation, the isolate of the living virus from the sample. So I compiled 3 independent studies that compare the performance of 4 commonly available test kits and compare that against the sensitivity and specificity of FIV isolation. And as you can see on the table, most point of care tests show comparable sensitivity and specificity when compared to FIV isolation. So any brand would do the job to detect antibody. But as I mentioned earlier, FIV point of care tests detect antibody against FIV. So there's some issue in the vaccinated cats. If you look at the result here from study of Mark Westman in 2015 and 2016 in Australia, the definition of FIV point of care test usage in his study is the detection of infection. Therefore, the test that cannot differentiate between unvaccinated cat or naturally infected cat and vaccinated cat have no specificity, and therefore IDEX SNAP test that he used in this study that detect P15, P24 capsid, and GP40, they cannot differentiate. The IDEX SNAP test cannot differentiate between antibody from vaccination and antibody from natural infection. That's why he gives 0 specificity for vaccinated cat when you compare SNAP to other tests. On the other hand, tests that aim to detect only antibody against GP40, technically, can differentiate between antibody from vaccination and antibody from naturally infected cats. As I mentioned earlier, because antibody against GP40 comes slightly later after infection, And also because the immunogenicity of GP40 is not as high as capsid protein, somehow vaccinated cat tend not to mount antibody against GP40. However, in the follow-up study from also Max Westman in 2017, he compared four different tests and follow-up after vaccination. So as you can see here, all tests that detect antibody against FIV give false positive tests, cannot differentiate between vaccination and infection at the, let's say, up to 6 to 8 weeks after vaccination. But the test that detect only antibody against GP40 will not, I would say, over time after vaccination, the antibody titer against GP40 will decline and disappear after 6 months of post-vaccination. And therefore, in this study, he concluded that you can use test kit that aim to detect antibody against GP40 after 6 weeks post-vaccination to test whether the cat is naturally infected with FIV or not. Compared to the test that aim to detect antibody against P24, it will always test positive, no matter how long after vaccination, because antibody from P24 is highly immunogenic and can be detectable throughout the, after vaccination, and cannot differentiate between vaccination and infection. So for the prevention of FIV, I would say the same strategy. You can use identification and isolation. Just bear in mind that point of care tests just detect antibody and cannot differentiate between vaccination and infection. In case you're quite certain that the cat haven't been vaccinated before, you should confirm with, let's say, molecular technique that aim to detect viral DNA to make sure that antibody positive come from vaccination or come from infection. And the efficacy of FIV vaccine that are available in the market, the Fblv FIV, which is a FIV vaccine that combines 2 clades of FIV, clade A, Petaluma strain, and clade D, Shizuoka strain. From study in Australia by Westman again, he's very FIV expert in the field right now. The protection rate of Fblv FIV vaccine cats is about 56%. So about, I would say, just above half and half chance of prevention or protection, but better than nothing, right? But the concern of Fblv vaccine is that whether it could provide protection between clades. FIV, similar to HIV, is one of the most clever virus in the field right now. It can hide the neutralizing epitope underneath the glycosylation shield, and therefore there is a high tendency that the vaccine could not provide protection between clades. And it also can interfere with the diagnosis because current point of care tests cannot, I would say, more or less cannot differentiate between antibody from infection and antibody from vaccination. At least up to 6 months after vaccination anyway. And also because of the regimen of the vaccine, you have to repeatedly inject the vaccine for the cat at least 3 times. So you increase the chance of injection site sarcoma. So I would say in case of like low risk cat, FIV vaccination is not very useful if you keep the cat indoor without any chance of contacting the virus. But if your cat is like, let's say, free roaming, so you might have to bear in mind and weigh the benefit and the risk, as I mentioned earlier, for the FIV vaccine. All right, to summarize the point of care advantage and drawback that I already mentioned earlier, for Fblv, all tests detect P27 antigen in the blood, and you can detect as early as 3 to 6 weeks post-infection. If the test result is positive, it could mean the cat is undergoing progressively infected cat, undergoing progressive infection. And I would recommend you retest the presence of P27 antigen in the blood about 12 weeks after the first test to confirm whether the cat is progressively infected or it can control and turn to be regressively infected cat. if the two tests, like, the first one is positive, the second one is negative 3 months apart, that means the cat can control and they are regressively infected and live similar lifespan to uninfected cats. However, if the test against P27 antigen become negative, you can interpret that into several different results. It could say that the cat is not exposed to the virus, or it just recently infected. You test the cat too early after infection, or the cat is already immune to Fblv, or the cat is regressively infected with Fblv, and you cannot detect antigen in the blood of regressively Fblv infected cats. And in case of the high risk exposure, I would recommend you repeat the test within the 1 month after the exposure event to make sure that you didn't test for Fblv antigen too early after infection. And anyway, if you in doubt, confirm with different techniques such as molecular technique, PCR for viral DNA target. For FIV, all test kits detect the same thing. I mean, antibody against FIV, but different target. So when you choose the test kit, choose carefully that which one that you want. Some might have higher sensitivity or can detect earlier than other kits, but some might not be able to differentiate between vaccination and unvaccinated cats, naturally infected cats. But usually you can detect antibody against FIV within 4 to 8 weeks post-infection, depend on the kit again, but usually 4 to 8 weeks is enough time, to detect Fblv antibodies. If the test is positive, be careful in the kitten's age, less than 6 months old, because the antibody might come from maternal derived antibody. So I would suggest to repeat the test after the 4 to 6 months of age, or just wait until the kitten is older than 6 months and do the test. Yep. And confirmation is only recommended in the very, I would say, low risk of exposure cats. For example, indoor only cats or cat with unknown vaccination history. If the test is become positive, I would suggest to confirm that with other techniques such as viral DNA PCR. However, if FIV antibody test tested negative, it is highly reliable. Yeah, but in case of high risk, I would suggest you repeat within 2 months post exposure, just to make sure that you not test too early during the course of infection. And that's it for tonight's lecture. I would like to give my gratitude to my workplace, Faculty of Veterinary Science, Chulalongkorn University, and to my mentor back at the University of Glasgow, Professor Margaret Hosey, and also to another affiliation that I belong to at the Chulalongkorn University, the Emerging Infection Disease in animals, and also Diagnosis and Monitoring of Animal Pathogen Research Unit, and also Pathogen Bank that provide me sample to perform some study, and also to BioGuard Corporation to providing me this opportunity to talk to you about FIV feline retrovirus today. Thank you so much for your attention.
Oh, very thank you, Dr. Navapong's very good speech. And now we may have leave the Q&A time. So any participant, you can leave the question to the message, or if you want to ask the question, please also let me know. I think I can maybe I can open the question.
Yeah, I can help you with that, Dr. Anton. Let me read the chat box.
Yeah, can you see the chat box, Dr. Namapong?
Yeah, I'm looking at the chat box right now. So there's one question from Dr. Sulapong. Okay, I'm sure he's from Thailand. So the question is, antibody test for FIV can detect antibodies passed in colostrum from an infected or vaccinated mother, which can be mistaken for infection in the kitten. True. Test negative, indicating no infection. Antibody test for FIV can detect. Okay, let me summarize later, okay? All right. So the question is, because FIV antibodies can be like passed in colostrum from the milking mother to the kittens. So the question is, when should we retest the kitten? So I would suggest 6 months of age to make sure that the maternal derived antibody is declined below the detection level. And also in vaccinated mothers, of course, the antibody can also like pass to the kitten in colostrum as well, whether it comes from naturally infection or from vaccination. So I would suggest 6 months of age for the kittens to confirm the infection, I would say. Is that answering your question, Dr. Surapong?
And now, if any guest or participant want to ask a question, you can leave the message, or you can open your microphone. Then I think you can to ask a question to Dr. Navapong directly. So, do you have any want to ask a question about the Dr. Navapong? And it's a good time to share his experience with us. You want to ask a question. So, do any have the question or to give the or want to share your comment with the Dr. Navapong's speech? Just can open the microphone. Sorry, please.
Okay, or is there any suggestion that you would want to provide me? Okay. There's one question about injection site sarcoma from Fplv vaccines. Of course, you can have injection site sarcoma from Fplv vaccine as well. Yep. So I would suggest, but I would say right now the current vaccine and most of the feline vaccines are without adjuvant anymore. So the injection site sarcoma incidence is decreased like dramatically compared to like 10 years ago. And I would say the guide right now is to, instead of like providing the vaccine to the between scapula of the cat, we tend to suggest to give vaccine like to the shoulder of the cat. But again, I would say the risk of injection site sarcoma is decreasing dramatically over like the past 10 years, I would suggest. Okay. Now another question. So I'll read through and summarize that to you all. Oh yes, the question is about another test called Fblv Retroviral test that can detect both the P27 antigen of Fblv and also the antibodies against Fblv at the same time. Yes, of course, that's the test of choice. I mean, I've heard a rumor that there's some company that try to incorporate detection of Fblv antibody in the test kit at the same time as antigen detection. And that would be the test of choice because you can differentiate. You can detect 3 exposure outcome of Fblv exposure. Let's say if antibody positive, antigen negative, it could either be abortive infected cats or regressively infected cats. But it is antigen positive without any antibody, so you can be sure that is the progressively infected cats. Of course, if it's the test of choice. But I'm afraid that right now that kind of test is not available in the market at the moment. And all the test kit that designed to detect antibody against Fblv is only available like in some laboratory. For example, the antibody against surface glycoprotein, the GP70, is only available in Scotland, in Glasgow. And the one against P15E is only available in Dr. Regina lab in Switzerland. It's only like in-house usage. It's no commercially available. It's a shame, but I hope one day we will have that test. Maybe BioGuard can come up with such tests. Okay, and yeah. So can you repeat again on how to differentiate field infection FIV from vaccine-induced FIV antibody? To be fair with you, I wouldn't suggest using point of care test to differentiate between naturally infected cats and vaccinated cats. I would suggest you use other method detection, which is, let's say, proviral DNA detection. That would give you, I would say, a more confirmatory result. I mean, cat without proviral DNA, that means it's not naturally infected, must be from vaccination. Yeah. But if you limit it to only point of care test, I would suggest you use the test kit that aim to detect antibody against GP40 only and not like P24. Yeah, that would be my thought. What is your recommendation for earliest Fplv FIV vaccination? So I would say after 6 months of age. Yeah. To make sure that maternal derived antibody will not interfere with the vaccine. Yeah. Again, FIV is a Q vaccine, so you cannot, like, I would say the maternal derived antibody will play an important role by, to limit the effectiveness of the vaccine. For Fplv vaccine, because there are several formats in the market, like you have the canary pox vaccine vector, you have the Q vaccine. So I would say if you really want to give Fplv vaccine as early as possible, go for the canary pox vector. That would be less interference from the antibodies. But make sure that you test for Fplv before giving the first vaccine. Is it 8 weeks or kitten need to test for Fplv test before vaccinated with Fplv vaccine? Yes, I would say, yeah. Of course, you would test against Fplv antigen before giving the first dose of vaccine. Or for this question from BioGuard Corporation, so the question is, can you comment on cat having sporodicosis concurrent with Fplv and FIV positive? What would be the success rate of wound healing? It's a very tough question. And I cannot give you the answer at the moment because I have no data in hand at all. But I would suggest if the cat is immune suppressed by the either Fplv or FIV, the success rate of wound healing could be slightly lower compared to like healthy cats. Yeah, but I would suggest like open wound treatment. I mean, quite sterile open wound treatment would increase the success rate. But again, I have no data in hand to answer that question. But I would love to dig more for you. Later, I can give the answer to Dr. Anton, maybe later sometime. I'm sorry. Okay, the other question is, does interferon or antiviral product like Verbagen Omega may eliminate or kill Fplv and FIV infection? As I mentioned in my slide, all retrovirus infection is persistent infection, so there is no cure. It will be infected for life. By giving interferon omega, I would say you increase the host immune level in hope that the host immune system can control viral replication. But again, how would you measure the treatment outcome? Without a proper treatment outcome, I wouldn't suggest, all the treatment that you give to Fplv or FIV infected cat are just hope For example, let me give you an example for HIV infected people. When you give antiretroviral drug, any regimen to the HIV infected people, you really have to measure two clinical readout. First one is CD4 T lymphocyte. The second one is plasma viral load. If you give antiretroviral drug to the cats, because you want to control viral replication, you really have to monitor that your drug really control viral replication. And I'm not sure in other countries apart from Thailand, but in Thailand, only the university lab or in the capital city of Bangkok that we are able to quantitate FIV or FEV viral load to monitor the treatment, but the cost is quite high. Yeah, and also for, let's say, CD4 T lymphocyte, the clinical readout for immunocompetent cats as the treatment outcome. Only university lab that equipped with flow cytometer can do that, and I'm not sure, but in Thailand we can do that in Chulalongkorn, but I'm not sure about other units. So of course you can give the interferon and monitor the clinical sign of the cat as a readout of the treatment, but you can never eliminate the virus if the virus is already integrated into the cell. Yeah. Does that answer your question? Another question is, will you recommend normal routine vaccination, let's say feline parvovirus in an FIV or FAV positive patient? Yes, I would recommend, but you might choose Q, the product that use Q virus instead of live virus to boost the immune response of the cats. But again, you can use like practice to lower the risk of infection in case of FIV and Fplv infected cats, which is very important. There's one study back in Glasgow that we compare two cohort of cats. One is in the shelter with like more than 20 cats in the same household. Another one is a cohort of 20 households, each with single cats. Over the period of 2 years, the cat in the shelter that have a chance to infect with other virus at all time because the densely populated population. Over the course of 2 years, only, if I remember correctly, only 5 survive, compared to another cohort that each household keep 1 cat. They live, I would say only 1 die from something else and not related to infection. So I would say for FIV and FELV positive patient, I would say control of population and control of infectious diseases exposure might give you better outcome, I would say. Again, now the question is about dimethylglycine as immune moderator to manage cat with FELV and FIV long term. How effective is it in your opinion? In my opinion, again, I don't have the number in my hand, but I would say I would put my opinion like this: the same as the question using interferon omega, without the mean to measure your treatment outcome. You can only monitor the clinical sign of the cats, and it's not good enough in my opinion. Yeah. So I cannot give you the long-term effect number right now, but if you see the cat show better clinical sign, yes, of course, why not? You can give the immunomodulator. Just be careful. Immune modulator sometimes could drive mitosis of the immune cell. And if the immune cells already integrated with retrovirus, you can reactivate viral replication as well. So just bear in mind, there is a pro and con of using immunostimulator in terms of retroviral infection. So I would suggest you find the lab that can help you monitor viral load, for example, to monitor your treatment. That would be a better mean of monitoring the treatment outcome. Another question is, in a highly endemic region, it is not useful to vaccinate, correct? Well, no. I would suggest in a highly endemic region, let's put it this way, in my own belief, I think in a highly endemic region such as Bangkok that I live in, I would say we have to use the vaccine to control infection. But the effectiveness of the vaccine really depends on your testing. You really have to make, you cannot just give vaccine to any cats that roam around the city, but you only give the vaccine to naive population. And over time, you will see the decrease in the virus. But again, in the big city like Bangkok that have at least 2 million of cats roam around, and mostly stray cats, it's almost impossible to use vaccine to control Fplv or FIV. Not to say rabies, the most effective vaccine control disease. We can still unable to control rabies in the big city settings. So I would say it's useful to vaccine in a highly endemic region, but you have to make sure you vaccinate the right population. That's what I suggest.
So it's a very good chance to ask a question to Dr. Namapong too. So do any vets have some opinion or share your comment or ask a question to Dr. Namapong? It's a very good chance.
Yeah, I would love to hear from you guys about like your practice, you know, in different countries. I really want to, like, for example, what is the prevalence of FIV and Fplv, let's say in Malaysia or in Philippines?
Yeah, even you can to open your microphone.
You can share me. Yeah, you can share your thought to me. I would love to hear that. Or what about Taiwan?
Yes, just you can open your microphone to don't be shy to share your comment. So Dr. Robert, you have any comment?
Yeah, it's very nice to hear such a wonderful webinar from Dr. Namapong, and I got a lot from today's webinar.
Yes. So anyone to share your comment or ask a question about this? Okay, so if so, well, we just give finally give the big hand to the Dr. Namapong and thank you. It's a very nice and amazing speech for this. And thank you everybody to participate in the lecture. And we will keep to do this and we to share our lecture course. And hope everybody can enjoy and can participate in next time. Thank you everybody.
Thank you so much.
Okay. Thank you everyone. Good night.
Good night. Thank you so much.
Thank you so much.
Bye-bye. Thank you so much, Robert. Bye-bye.
Okay, thank you, Dr. Namapong.
Bye.